page 33. It's another solving trigonometric equations problem. But it's got a lot going on, or it appears to have a lot going on. So the first thing that I notice when I look at this equation is that I have a squared term, something that's not squared, and a constant over here. So what I'm going to do first is I'm going to move everything to one side so that I have 0 on the other side. So I'm going to add 1 here, and I'm going to add 1 here. All right. So I end up with 2 cosine squared t plus 3 cosine t plus 1 equals 0. And then I'm going to do a substitution for cosine. So I'm going to say that cosine t equals, we can use anything, but I'm going to use x because it will look very familiar if we use x. So everywhere I see cosine, I'm going to replace it with x. So I get 2x squared plus 3x plus 1 equals 0. And what we notice that we have here is a quadratic equation. So we're going to factor this like we would factor any other quadratic equation. You guys can use any method you want. I'm going to do factor by grouping. So I'm going to multiply a and c. People also call this the AC method. So 2 times 1 is 2. The b term is 3. I want to think of 2 things that multiply to 2 and add up to 3, or 2 numbers that multiply to 2 and add up to 3. Those numbers are 2 and 1. So I'm going to come back here and split up the b term as 2x plus x instead of 3x. Now I have this. So I'm going to factor whatever I can out of the first 2 terms. So I get 2x times x plus 1. And then I'm going to factor whatever I can out of the next 2 terms so that I match this binomial here. So I'm going to factor 1 out. And now if I look at this term and this term, I can factor an x plus 1 out. So I get x plus 1, 2x plus 1 equals 0. And now, I'm going to set each one of these binomials equal to 0. So x plus 1 equals 0, and 2x plus 1 equals 0. And then I'm going to isolate these for x. So this one becomes x equals -1. This one becomes 2x equals -1. Divide by 2. We get x equals -1/2. And now we're going to go the other way with the substitution. So everywhere I see an x, I'm going to replace it with cosine t. So I get cosine t equals -1, and cosine of t equals -1/2. We'll start with cosine t equals -1. That occurs here because the coordinates of this point are -1, 0. X is the, or cosine is the x coordinate. All right? So that angle is going to be pi. All right, so our solution over here is going to be t equals pi. And now we've got to deal with the other one. So cosine of t equals -1/2. That occurs in the second quadrant, or we get a negative value in the second quadrant and the third quadrant. So the first one occurs at 2 pi over 3. The coordinates of this are -1/2 and √3 over 2. Right? And then the other one occurs at 4 pi over 3. Right, and the coordinates of this point is -1/2 and -√3 over 2. So we get t equals 2 pi over 3 or 4 pi over 3. So those are our solutions for the intervals from 0 to 2 pi. If we want to do for all real numbers, we have to think about it, like how spaced apart these solutions are. So if I rotate 2 pi radians, if I had another 2 pi radians, I come back to that same spot. And if I go the other way, I also come back to that same spot. So for all real numbers, we're going to have that t equals pi plus 2 pi n. And I'm not going to write this down, but you guys should write it on your paper. N is an integer. Or if we start with 2 pi over 3, we actually have to rotate around 2 pi for that one too. So we're going to have 2 pi over 3 plus 2 pi n. Remember, n is an integer. And then the last one, 4 pi over 3, you've got to go all the way around to get another solution.